All right, so this is going to be my 5-minute presentation on augmented feedback and how it can support skill transfer and reduce high-risk injury landing mechanics. So this was a double-blind study, and it was randomized controlled laboratory study. So the purpose of this study was to find useful and effective method for clinicians to determine the success of augmented feedback during their screening process. So it wanted to produce a simple method of screening to evaluate anterior cruciate ligament injury risk, so ACL injury risk. And the hypothesis here was through augmented feedback, it would affect their landing mechanics. So during a tuck jump test or the drop vertical jump landing test, it would decrease the frontal plane knee angle. So when your leg goes in, so that'd be knee valgus, this would avoid ACL injury risk. So through coaching, they wanted to see if they could coach someone in their landing mechanics and land in a better body position. So the methods of this study were it was 37 female participants, mean age was 14.7 years. So this is relatively young athletes. They had participants videotaped for 10 seconds in each of these trials. So they were running on a treadmill and they were performing tuck jump tests. So they were all also coached of similar strength training and exercise protocols. So they were videotaped while running on a treadmill and performing tuck jump tests. So they had the frontal plane and the sagittal plane. You can see on the picture on the right. They had both views and they were seeing their knee and thigh motion, foot positioning, and then their plyometric technique and how they can get coached up. So they're given 2 coaching cues between each trial. And they were also shown the video during these coaching cues so they can actually see their mistakes and how they can fix them. So the 2 groups in this study were the augmented feedback group, which received feedback during the tuck jump video, and the control group, which was receiving feedback during the running on a treadmill. So it was either or here. So it was either the augmented feedback group only received feedback during the tuck jump, and the control group only received feedback during the running on a treadmill. So the 2 measurements that were taken during the tuck jump test were the frontal plane knee angle, so how far your knee went in or out. So you want to see the knee angle there of 3 trials. So this is going to be the average of 3 trials, and then the most extreme knee abduction. So they wanted to see your knee movement when it was the most extreme and kind of compare it to the control and the augmented feedback group. So the results of this study were the mean reduction in the frontal plane knee angle was for the augmented feedback group, it was 37.9%. For the control group, it was 26.7%. So there was a bigger reduction in the augmented feedback group through the coaching cues and the landing mechanics. The most extreme the DVJ trial change in the augmented feedback group was in the left leg. There was 37.7% change in the left leg knee angle. And then this was the most extreme, so with the most extreme abduction. And then in the right leg, it was 40.1%. So this is the percent changes in the augmented feedback group. In the control group, for the most extreme, there was no change seen. So for the augmented feedback group, they had the larger reduction in the frontal plane knee angles, so the knees going in, and they had the biggest reduction there. And then the control group, there was not really seen much of a change. So there was a bigger reduction with the coaching cues. So in conclusion, female athletes may display 1 or more deficits while performing a jump test. So this could be a good indicator of their risk for ACL injuries. And also this showed that correctional augmented feedback, so through the coaching cues, they can actually improve their landing mechanics to reduce injuries. So you could tell them land with both feet at the same time, bring your knees up at the level rate. So through these coaching cues, you can actually improve their landing mechanics and also their knee angles. So the feedback supports the acquisition of skills and reduces the risk of reduces the risk of injury because of the neuromuscular adaptations. So through the feedback, they're able to acquire skills and reduce their risk through the neuromuscular adaptation and their knowledge of skills there. So thank you, and hopefully this was a good study.